Today we're going to move to section 8.3, which is the law of cosines. In 8.2, we saw that the law of sines could be used in some triangles to solve for the missing side lengths and angle measures. But you could only solve the law of sines problem when you knew an angle and a side that were opposite of each other. We're going to use law of cosines to find more triangles that we can solve. Law of cosines is actually related to Pythagorean theorem. You've learned that if you have a right triangle with angle C as the right angle, and then legs A and B, and hypotenuse C, that C squared is equal to A squared plus B squared. In geometry, you said the converse of this was true. If C squared equals A squared plus B squared, then angle C had to be a right angle. If angle C here is not a right angle, there's two things that can happen. If I look at the side lengths and C squared is less than A squared plus B squared, in geometry you learned that angle C had to be acute. And if C squared was greater than A squared plus B squared, we learned that angle C had to be obtuse. Pythagorean theorem only works when you have a right triangle. Law of cosines is an adjustment to Pythagorean theorem that allows you to find missing sides and angles in some cases when it is not a right triangle. The law of cosines looks like this. C squared equals A squared plus B squared. That's the Pythagorean theorem part, and here's the adjustment. Minus 2AB cosine C. This is angle C, this is side C. When you use law of cosines, the letters may not be the same. The key is that this side is opposite this angle. So in some cases, you may use A squared equals C squared plus B squared minus 2CB cosine A. These letters can change around. The key is just that the side that is on the opposite side of the equation is opposite the angle. This does actually work for right triangles because in a right triangle, you plug in 90 degrees and the cosine of 90 is 0. So all of this goes away. So law of cosines is kind of a more expanded rule that would work for all triangles. Here's an example where you can use law of cosines. Here we have side, angle, side. We could not use law of sines for this because we do not have an angle and side opposite of each other that we know both of to plug into one of those ratios. What we want to do is figure out what we can find first using law of cosines. We have side, angle, side. We can plug in to find the side that is opposite that angle. So again, law of cosine says C squared equals A squared plus B squared minus 2AB cosine C. In this case, this side and angle are going to be side R and angle R. So we're going to find side R first. And to do that, we're going to plug in R squared equals, and then this A and B, it doesn't matter which one is which. You're just adding the two side lengths squared to each other. So I can write them in any order. 45 squared plus 52 squared minus 2 times 45 times 52 times the cosine of angle R, which is 36 degrees. Again, you're going to make sure that your graphing calculators are in degree mode in order to do this because all angles are given in degrees. You're also going to make sure you can type all of this in your calculator in one step. That's R squared. Don't forget to take the square root of your answer at the end. And in this case, you should get that R is 30.71 centimeters. For today, we're just going to find one missing side or angle, and you're going to do this work on Delta Math. The other case where you can use law of cosines is when you know all three sides. And in this case, we could use law of cosines to find any angle, but we want to find angle Q. Again, we need to identify angle Q is opposite of the side that's 250. So when we plug in the law of cosines, if I want to find angle Q, the 250 is what goes on the other side of the equation. 250 squared equals 175 squared plus 225 squared minus 2 times 175 times 225 times the cosine of Q. Now, we want to solve for this angle Q, which means we need to get cosine of Q by itself and then use the inverse cosine to find the angle. When you do this, we're going to subtract the 175 squared and subtract the 225 squared first, so it looks like this. Don't forget this negative is still there. Then all of this is multiplying cosine of Q, so we're going to divide both sides by negative 2 times 175 times 225. Negative 2 times 175 times 225. And check yourself and make sure that you can plug this into the calculator correctly. That's going to give you cosine of Q. So when we want to get Q at the end, we're going to have to take the inverse cosine of that fraction. And when you do these problems, you're always going to show me the very first step, and then you're going to get me your final answer, which in this case, angle Q is 76.23 degrees. And we don't have to worry about any supplements or anything else with this. But you're going to make sure you show me everything plugged into the equation and then the final answer. You do not need to show the interim work unless you need to do that in order to get the correct answer. For today, you're going to do some delta math problems, and then tomorrow you'll be doing book work. Let me know if you have any questions.